sorry I'm not available in Swan at the moment, but the organizers, they told me that I could still provide a video submission. So let's start. Thank you all for attending this session. I hope you guys like it. So, as quick round of introduction, I'm Utkarsh Bhatt. I work for the Ceph Orchestration team at Canonical. We make sure that the latest and greatest of Ubuntu is shipped with the latest and greatest from Ceph. Moving on, this presentation in particular is about MicroCeph and any flexible Ceph orchestration features. But before we move on to any of that, let's just ask ourselves a very simple question. What's the agenda of this presentation? So, through the course, we'll talk about what's MicroCeph and why MicroCeph is. Once we are beyond these two psychological, philosophical questions, we'll go on to deployment. We'll take a look at network and disk configurations, configurations for local reliability clients. We'll quickly discuss about microcloud, what it is, and then we'll be back to discussing feature works for MicroCeph, such as service placement and cluster configurations. The Rails Gateway Keystore integration is an important piece of feature work that was based on cluster configuration, so we'll talk about that as well. And then we'll go on ahead for a short demo for a very interesting use case of like a single node Ceph cluster with replication disabled, so like list of footprints on the disks. Backing a Rails gateway that serves S3 and has, this cluster has like the network and public networks segregated to different subnets. Once we're done with the demo, we'll quickly discuss about ongoing feature works for remote replication, orbiting mirroring in particular. And then with a small outro of MicroCeph, we'll conclude this whole presentation. So, let's start with a simple question. What's MicroCeph? And some of you may or may not have already discussed about it, seen it, come across it, tried it, maybe even are using it. But it is still worthwhile to have a quick discussion for what exactly MicroCeph is and how it does what it does. So on a very technical level, MicroCeph is a confined snap. Not all snaps are confined, but MicroCeph is. It implies that it runs in complete isolation on the hosts, and all of its dependencies like the Ceph packages are lived inside the snap. So it is in no way dependent on the host to provide any of those dependencies. And snaps, they use like a very interesting channel topology for the versioning, and this allows for an operator to quickly refresh a particular channel of a snap. So an operator can request a snap to go from latency stable to reef edge, these two being different channels, and the snap carrying the packages inside it implies that when you switch between two revisions of a snap, you also switch between the packages. MicroCeph in particular has like its versions named as Ceph versions, so read snaps deliver read, flimsy snaps deliver flimsy, while as the stable edge and candidate risks, they suggest the kind of risk associated with the changes that have gone inside. So recent changes go to edge, they bake in, they get promoted to candidate, they bake in a little more, and then eventually get promoted to stable. All of this allows us to deliver the same beloved Ceph packages that we do for any Ubuntu LTS distribution. And along with the microcluster intricacies, we are able to provide an effortless deployment experience for the users and an operational experience with minimum overhead. So let's move on to the slightly complicated, more psychological question on, even though when we know what MicroCeph is technologically, why actually is it needed? So the MicroCeph design philosophy stems from the micro design philosophy, and it in no way implies that MicroCeph is a micronized or a minimized version of Ceph. So it's the same Ceph, but the micro stands for something else. In the micro design philosophies, if expressed correctly, start with micro prerequisites. So it is essential for Ceph consumers, more and more Ceph consumers, ideally everyone, to start to consume Ceph. It is essential that the minimum barrier of entry in terms of technological know-how, in terms of like physical machines, lock devices, what is all required to run a Ceph cluster. It's essential that we use this value, and MicroCeph does this by having a very little set of prerequisites to have a Ceph cluster running. Basically, the laptop is sufficient to get started. You can have your own Ceph cluster up and running in the laptop. This implies that more and more people would be able to access Ceph as a technology, deploy Ceph as a technology on their local machines, see it in action. And the ability to deploy a single node Ceph cluster actually opens up quite a lot of interesting use cases. So take the example of a test cluster. Sometimes there are situations where you need the output from that particular peculiar Ceph command, know the exact state, format, what are the keys available in the output, how exactly does it work, will it work if you try to change your pool mode for an enabled RBD mirror pool from image to pool, does that work? And to be sure, you can only be sure once you have a Ceph cluster, once you do those operations on a Ceph cluster. And the ability to quickly spawn a single Ceph cluster actually helps such cases. It also helps with trainings. So the more complicated it is to deploy a Ceph cluster, the more complicated it becomes for anyone working with the Ceph cluster. It scares them of breaking things up inside a Ceph cluster. But with MicroCeph, it's actually pretty easy to just purge it out, remove all of it. And since it is isolated from the host, once it is removed, there are no traces remaining of the previous Ceph installation. So you can just cleanly remove it out, install it again. If it ends up in a state that is not recoverable, ideally Ceph is pretty designed to be for scale, designed to be with like failures. So ideally it should recover from those failures, but it arrives. Another interesting use case that is enabled by the single node feature work is CI. So say for example you have a situation where you don't have to test Ceph itself, but an application that uses Ceph to provision storage. Say an application that consumes S3 from Ceph. So you can have a single node Ceph cluster up, backing up Rails gateway, which then supplies or provides the S3 APIs for your application to consume. And all of this can be packed in on a small machine, maybe a different runner. So you can have an application, the MicroCeph cluster, all of them running there, doing all those verifications inside CM. This also enables you to start small, maybe with just a single machine, and scale only when needed, required by business scenarios, business use cases, and whatnot. So, done with the micro prerequisite, we move towards the next micropsychology, next micro design philosophy in MicroCeph, and that's micro distractions. So, for all of us who have had work with Ceph, if I request you guys to take a look at both the images on the left and the right, and associate either one with Ceph, I'd be surprised if anyone ends up calling Ceph simple as opposed to complex, focused as opposed to general purpose. It is well understood that Ceph is a general purpose storage solution designed to be a unified solution for block, object, or files. And the general purposeness has the complexity implicit inside. So any application that's designed to be general purpose, it cannot assume things, right? So an operator is required to configure it to work, like for it to work the way we want it to. It's a little different with MicroCeph. So with MicroCeph, we work on a philosophy of sensible defaults, flexible configurations. So ideally, all the operations should function on a standard sensible set of defaults, which even if not provided by the users are considered by MicroCeph itself. And if a user ends up in a situation where they want something out of the standard sensible default, a non-standard port configured, or a different network or a different subnet to be configured for the cluster network. All of these should be configurable still, but not mandatorily required for any operations. And we'll see much more of these in the upcoming discussion on demos. Let's take a quick look at the simple deployment procedure. If you take a look at commands on line 1, 4, and 6, you realize that you only need 3 commands to get a Ceph cluster up and running. If you're used to doing verifications, you also need the command on line 13 or the command on line 16, just to make sure that Ceph commands are working, the cluster is up and running, and whatnot. But effectively, installing Snap, interestingly from Squid channel, which means that we do have Squid Ceph up and available. Anyone wishes to try Ceph Squid can basically just install the Squid Snap and get started. So installing the Snap, bootstrapping the cluster, which starts the Mon manager and the MDS services, and adding disks, which is basically the OSD service. It's sufficient to get your OSD like Ceph cluster started through MicroCeph. And if you look at the command on line number 6, there's actually something even more interesting there. So the parameter for this add states loop UG3, which basically implies the MicroCeph, it says you need to create 3 loop file-based OSDs. So these are actually files of 2 GB sizes, which are backing the OSD daemon, not actual block devices. Why do we need such OSDs? So in some cases, block devices might not always be available. Say for someone who's testing out MicroCeph on their laptop, they might not have access to a free and available block device. And in such cases, it becomes essential for us to allow for such adjustments. So obviously, a cluster such deployed is not suitable for any kind of CS storage use case. However, it is still sufficient for you to, like for the Ceph cluster to get started and for you to have an access to a Ceph cluster. So it helps. Bootstrapping with dedicated networks. So in the previous example, we see that if you do a simple MicroCeph cluster bootstrap, it works. You bootstrap the services required, Mon manager and metadata services. However, it also allows you to provide the cluster network config option and public network config option, which we will use in our demo up ahead, to configure 2 separate subnets to be used by the public network and the cluster network. You can also provide the MicroCeph IP and Mon IP, and MicroCeph will then request, or respect rather, we provide the configurations and will only use these for spinning up the MicroCeph daemon and for the modern daemon. Adding disk. So adding disk is one such operation which can, on MicroCeph particularly, which can range from a very simple op, like the loop op, to a very complicated op where you are providing block devices to enroll as OSDs, you are requesting Microsoft to write them, encrypt them, additionally passing on dedicated block devices for an EV as well, which can also be wiped and encrypted. So it's like a permutation from these flags could be used to have the desired effect for OSDs. Or you may end up using none of them and just delete devices from this inside. One of the interesting flags available here is the all available flag, which basically suggests MicroCeph to use all the available block devices and enroll them as hosts. A quick discussion about MicroCloud. MicroCloud is a fully functional cloud solution which uses MicroCeph, MicroOven, and Lexi. So to get a highly available cloud solution up and running. This is interesting because Lexi is one of the consumers of MicroCeph, which can take advantage of the RBD client cache configurations, which we'll be talking about soon. So before we go there, are two types of complexities that Ceph products. Ceph services. One is the complexity of deployment. So how do I get started? How do I get Ceph cluster up and running? How can I add more services? How can I add disks? How can I configure networks? And then there's operational complexity which arises from doing data ops, where you configure your services for a certain kind of desired performance, where you configure your client configurations, where you plan additional services to your subcluster. And MicroCeph has an interesting approach of dealing with both. So up until now, we've seen how MicroCeph eases the deployment process, and from now onwards, we'll be taking a look at the future works that enable MicroCeph to deal with the complexity of operations. So if you work with hosts where the virtualization client is actually located with Ceph, so both Ceph services and labor clients like QEMU or KVM live on the same host. In such cases, they can take advantage of the Ceph configuration file available on the host, read client configurations directly from the Ceph file, and respect them while consuming RBD storage from Ceph. So this is interesting, but if the manually is very complicated, so if you have 100 nodes in your Ceph cluster, I cannot expect an operator to go and configure key values in Ceph files manually on a 100 node Ceph cluster. So there needs to be some automation around this. And MicroCeph has a very neat abstraction of simple key values which can be configured for global effect or for particular hosts. And MicroCeph fetches all of these records. It finds a clean way of applying all of these configurations on each host, and then ends up updating the Ceph file for each one, which we'll see a little more closely in the demo. Service placement. So MicroCeph can enable the mon, manager, metadata, and Rados gateway service on any particular node that you request. It can also migrate services from one node to other. It can vacate a host that has reached end of its life in the Ceph cluster operations, and they all use the same framework internally. So if the particular example that has been shown on the screen is for the Rados gateway daemon, and we can also take a look at the additional parameters that we could provide for starting the Rados gateway service. Interestingly, here as well, we're not required to provide any of the parameters and we'll see in the demo that even when we don't provide any, MicroCeph will still default to some sensible values and we'll get the Rados gateway service up and running. Cluster configuration. So in a Ceph cluster of say size 50 nodes, if you change a particular configuration, it gets propagated to the whole cluster as soon as you do it, because Ceph has an internal KD store for such configurations. Still, all the services that require or that take effect from that particular configuration, they're required to be reloaded so that those effects, those changes can take effect. And in this particular situation, it could be tricky if you're doing those manually. So reloading services manually on a very large cluster is actually a very tricky operation and may end up in a situation where some of your services are down, the storage cluster is not completely up, services are degraded, and you're just not in the ideal position to serve for some time, at least for the time the services are back up. MicroCeph cluster configuration has two views on this, so it has the Ceph configurations that needs to be configured, but it also has an internal mapping of daemons which needs to be reloaded for that particular config to take effect. So whenever a supported key configuration is changed, MicroCeph goes in, restarts all of the affected daemons sequentially across the cluster. So at no point of time there are more than one service down, and you end up having a smooth transition for that particular configuration across the cluster. Rados gateway keystone integration uses the cluster configuration to implement an interesting integration with the Rados gateway and keystone. This is basically a set of configurations that you can configure on the Ceph cluster, on the MicroCeph cluster, and using the configurations, then a user can then consume S3 or Rados gateway through a Keystone identity service. Let's go to the demos. In this particular demo, we'll see a single node, Ceph cluster, which has replication disabled. Is backing Rados gateway, which will serve as S3. And for this particular environment, the network subnets for the public network and the cluster network are segregated. So let's start the video. Here. So we do the snap install of MicroCeph. If you look at the channel parameter, you see Squid Edge. So we're basically installing Squid Ceph in the server. Once the snap is up, we will just quickly check the Ceph version just to make sure that we don't have anything else. It's 19, so it's good. Now let's go in and see the network configurations on the host. So we can see that there are some subnets available to consume, and we'll move ahead with cluster bootstrap. But unlike the simple example where we didn't provide any parameters, we will be providing the cluster network subnet and the public network subnet for MicroCeph to spawn services on. So once this is done, while MicroCeph starts or bootstraps the Ceph cluster, we can now figure out or verify whether the requested configurations are being respected. So we'll take a look at the status. We see that the metadata service, manager service, and all services are up. We take a look at mon down and just make sure that the addresses are from the requested public network that we provided MicroCeph to bootstrap from. And then we take a look at the cluster configurations just to see that the cluster network config key is also configured to the desired value that we provided. Once that is done, let's just quickly add some disks. So when we do disk list, we see that there are 3 available disks on the system that could be enrolled as block devices backing the Ceph OSD table. And we see the Ceph status to have 0 OSDs in and out. We just quickly go and add the block device with the provided path. In this particular example, I was required to wipe it because this particular disk was being used in previous experiments as well. So once you provide the wipe flag, it is able to spawn the OSD table successfully. You can see that one OSD is in and up. We just quickly go and use the all available flag to enroll the remaining block devices as OSD as well, and it will also respect the white flag provided for both of those. So once those enroll up, they are done. We now have, if you take a look at the configured disks, we'll see that there are 3 OSDs configured, and we can also see the OSD number that each disk maps to. In the Ceph status, we can see that 3 OSDs are in and up, and it will take some time to settle out. So let's just move forward. Let's disable the application now. So MicroCeph exposes the pool command, which has the set rf child command, which allows you to configure the replication factor for any or all pool, all being represented by the star wildcard character. So if you do that, it configures the default replication factor for all future pools to be 1. So let's just take a look at the Ceph status. Ceph is already complaining about the card manager pool, which says one pool have no replicas configured. What if we create new pools? Let's just quickly create a new pool called test, and just make sure that the test pools was not enabled for any application, but once we do see that Ceph complains that 2 pools are now unconfigured without any replicas. So it implies that the new created pools respect the replication factor configuration that we do. Let's take a quick look at client configurations. So let's just take a look at list. They are then configured. We now set the RBD cache config to true. without any parameters, so it will take a global effect. If we cat the configuration file available at var snap MicroCeph current conf, we can see that the RBD cache config is set to true. But if we go ahead and do like a host specific config with the value false of this particular host, we can now see that the list contains both of these records. These are required to apply them cleanly, but the host specific configuration takes precedence, takes priority while being applied. Let's just move ahead with service placement. So we try to enable, so if you take a look at the enable command, we see that the metadata service, manager service, spawn service, and radio gateway services are up and available to be spawned. But for our use case, we will take a look at the radio gateway service, which have all these parameters available to be configured. But for our use case, we'll just move with the sensible defaults. We'll trust MicroCeph to get us a radio gateway up and running, and hopefully it will. So while it spawns, let's just quickly move up. Let's take a look at the system status of the service, and it shows active and running, which means that the Rails Gateway service has been spawned up. We will now quickly create a Rails Gateway admin user with some preloaded keys that my S5 command application already has, so it won't be required to be reconfigured. We will now perform some operations using S5 command, a simple list. We will try to create a new bucket. We'll call it Ceph days. Let's just do that. Once the bucket is up, let's copy a locally available file. So just to make sure, the cluster usage is 139 megabytes at the moment. Let's just copy a locally available file to the newly created bucket called Ceph days. And once that is uploaded, which it should soon, you can now take a look at the list plus the Ceph days bucket and also the Ceph status for the cluster, which shows that the usage of the Ceph cluster is increasing because of the newly added file in the Ceph cluster. Moving ahead, let's take a look at cluster configurations. Just as an example for the Rails Gateway Keystone integration feature work, you can do a config list, see already available configurations. You can also do a config set for the suggested config keys. The actual activity of setting up, so if you do a list, you'll see that the configuration is persistent in the cluster. But the actual activity of doing the Rails Gateway Keystone integration, it's left as a take-home activity for the audience in real time. So this would be the end of the demos. Thanks for your patience for this. Let me just stop this up and try to move to the next slides. Okay, ongoing works. So at the moment, there are some interesting feature works that we're working on. One of them is remote replication, which as a base required is to have the ability to be aware of a remote subcluster. The tokens exported in this process are quite similar to the node tokens exported while adding new nodes to an existing cluster. The hash tokens contain important information like the SSID, monitor addresses, and a newly generated client key that is passed on inside the token, read by the remote MicroCeph cluster and used to communicate with the Ceph cluster. So both of these tokens get their own client keys, which they can use to talk to each other. Building over this, we are working on RBD mirroring as a feature work for remote replication. It's a little complicated, and this is why we are trying to make sure that the overall experience of the user trying to configure mirroring is as simple as it is for other operations. This is like a finite state machine which shows the events and transitions between different states. And if you find this interesting, if this piques you, you can visit our repository and website and try it out.